In this lesson, let's learn about Windows DNS functions. The objectives of this lesson is to learn about all the DNS functions that a Windows DNS server can perform to resolve the queries from its clients. Then we will sum up our lesson with a diagram. Let's learn about 4 lookup zones. As you may know, 4 lookup zones of a DNS server is a place to create zones for domains and their records, for which the DNS server can look up to resolve DNS names into IP addresses. The DNS server then becomes the authoritative DNS server of the domains created in its 4 lookup zones. As you can see in this screenshot, when you open DNS Manager, you will see the DNS server name. In this case, it is GPVDC01 and it has 4 lookup zones. And here are all the zones created in the 4 lookup zones of the DNS server GPVDC01. When you click on a zone for a domain, for example, itlifeskills.local, you will see all the zones for each child domain and the DNS records for the domain. So in this case, whenever the DNS server GPVDC01 receives a query to resolve DNS names into IP addresses for the domain itlifeskills.local, it will look up the records in the 4 lookup zones for the itlifeskills.local domain to find the answer to return to the client. If it does not find the answer, it will return with an error message back to the client. Let's move on to reverse lookup zones. As you may know, reverse lookup zones is a place to create zones for IP subnet in address upper domains which contain pointer records for which the DNS server can look up to resolve IP addresses to DNS names. The DNS server is the authoritative DNS server of the IP subnet domains created in the reverse lookup zones. So in this screenshot, we created the reverse lookup zones for the IP subnet 10.0.0 and we created the pointer records to map 10.0.0.10 to the server gpvdc01.itlifeskills.local, which means whenever the DNS server gpvdc01 receives the query to resolve the IP address 10.0.0.10, it will search in its reverse lookup zones for the subnet 10.0.0 and it will find the pointer records and it will return the server name gpvdc01.itlifeskills.local back to the client. If the client query for any other IP addresses, it will return with an error message back to the client. As you may know, delegation is a technique to reduce the workload for the current DNS server when it comes to handling the requests for the child domains created in 4 lookup zones or reverse lookup zones. Delegations contain pointers to the authoritative DNS servers of the child domains. Delegation simply tells the DNS server to query the DNS servers specified in the pointers when it receives the queries for its delegated child domain. As you can see in this screenshot, we delegated the child domain hq.it/liveskills.local to either LHPVDC01 or OPVDC01, which means whenever the DNS server GPVDC01 receives the query for the records in the child domain hq.it/liveskills.local, it will query either LHPVDC01 or OPVDC01 to find the answer to return to the client. If it doesn't find the answer, it will return to the client with an error message. As you may know, delegations can only be configured for the child domains. For any other AD domains in the same forest, it is possible to configure stub zones which contain pointers to the authoritative DNS servers hosting the domains. The current DNS server then becomes the recursive DNS server of the stub zone domains. As in this screenshot, on the RPVDC01 DNS server, we configure the stub zone it/liveskills.local, which contains the pointers to the DNS server GPVDC01, which means the DNS server GPVDC01 is the authoritative DNS server for the domain it/liveskills.local. Now, when our PVDC01 receives any request to resolve DNS names to IP addresses for the domain it/liveskills.local, it will act as the recursive DNS server and send the recursive query to GPVDC01 to find the answer to send back to the client. Let's now learn about conditional forwarders. As you may know, conditional forwarders is a place to create domains and pointers to DNS servers that have information about the domains. The DNS servers specified in the pointers can be authoritative DNS servers or recursive DNS servers of the domains. The domains created in the conditional forwarders are usually the internal domains, but in a different forest. The current DNS server becomes the recursive DNS server of the domains created in the conditional forwarders. As in this screenshot, on the DNS server GPVDC01, we configure conditional forwarders for the domain ciscoskills.local, which contains the pointer to the DNS server at the IP address 10.250.0.10. Now, when GPVDC01 receives any request to resolve DNS names to IP addresses for the domain ciscoskills.local, it will act as the recursive DNS server and send the recursive queries to the DNS server at the IP address 10.250.0.10 to find the answer and send it back to the client. As you may know, to resolve internet queries, Windows DNS servers usually use folders. Folders contains a list of external DNS servers for which the current DNS server will send the recursive queries for DNS records of the domains that it cannot resolve. The current DNS server will function as the recursive DNS server to find the answers. So in this screenshot, we configure the DNS server RPVDC01 to use Google DNS at the IP address 8.8.8.8 as its forwarders with the option use root hints if no folders are available. Now, when IPv4 receives any queries for external domains on the Internet, IPv4 will send the recursive queries to the Google DNS to find the answer and send back to the clients. If the Google DNS server is not available, it will use the root hints. Now, when the folders are not available, the current DNS server will send iterative queries for DNS records of the domains that it cannot resolve to the root DNS servers specified in the root hints. As you know, sending iterative queries usually takes longer to find the answers. Therefore, it is better to configure the current DNS server with folders than letting it use its root hints. This diagram sums up our lessons. You are assigned to figure out how a DNS server resolves a query for each type of domain.